Yeah, I'm always here for the technical update. So I will give you like a little bit insights what we're working on in the OPC Foundation and OPC UA working groups mainly. I think we saw that already this morning from Stefan and from Uni that we have already some history with the OPC UA, and there was like the last release we had was in I think July 2015 with a few new features, and you also saw the IEC specification. That's more or less a mirror of the OPC Foundation version with a little bit delay. So what's currently available as second edition in IEC is more or less matching what OPC UA 1.02 is, and that was also part of that work for the second edition, was to have the first companion specification available as IEC version. And the reason, and that shows the reason why we did IEC, is if other IEC standards built on top of OPC UA, which was one of the ideas of OPC UA from the beginning, is to provide a communication infrastructure for other standards that mainly want to define information and not how the information is transferred. And if such standards are IEC standards, they require that what they build on top is also IEC standard. That was the reason why we added OPC UA to IEC to start with. And since FDI, field device integration, is also using OPC UA and is also IEC standard, their requirement was to have everything that they build on top as IEC, so that includes the OPC UA for devices specification. So that's the reason why we added the first companion specification also to the set of IEC versions. And we're currently working on to add also Part 12 discovery to the portfolio of IEC specifications. But this is also like one that is already released as an OPC UA spec. And like I think Stefan stressed this already today, OPC UA is a communication infrastructure that provides, for sure, also protocols, but provides security, platform-independent vendor interoperability, and it provides also like object-oriented programming capabilities to describe information. And so the OPC UA really defines how information is exchanged, and domain experts define the what. And then we have, for the communication, we have a client-server model. So OPC UA defines a list of services, like browsing the available objects, available nodes, reading data, writing data, calling methods on the server, subscribing for events. So these are standard services. And to transport these service request responses, there are different protocols. We have an optimized binary protocol that was defined by OPC UA, but we also use web services or HTTPS REST-like services. And we are working on additional protocols, like one option for the future is WebSockets with JSON encoding, for example. So the whole information modeling capabilities in the services, they stay stable, and maybe we add new protocols over time. But that's just in the lower levels of the communication stacks. We will come back to that picture later, but because that's one of the things we're working on to extend that picture. So I want to talk about the work items the OPC UA working group is mainly working on at the moment. And we collected a lot of new use cases over the last 5-6 years. And one is that was first brought to us by like smart grid environments, but it's more and more common requirement is to have communication between client and servers where both partners are behind the firewall. So there's no way to talk directly between like a device and the software in another network. so we need some kind of relay functionality for like a cloud relay. Then we have also since a long time the requirement for controller-controller communication, and we have already solutions for that, but there's more requirements for optimization and especially also for real-time communication between controllers. And then also the integration of devices, controllers with message brokers, with the cloud environments to send data to a cloud environment. And also the scalability is a more and more important question with having more and more OPC UA devices and to like have thousands of them, maybe millions. So what we are working on is to extend this picture with a publish-subscribe communication model in addition to the client-server model. And the basic, we want to follow a similar concept like for client-server. The general concepts and the mapping to OPC UA information is done in an abstract model that is independent of the transport protocols. And then we work on different transport protocols to then transport the OPC UA data in an OPC UA format or even in like a JSON encoded format that can be consumed by non-OPC UA applications. So if you look at the current client-server model, we already have something like subscriptions. So a client can go into a server and ask for data streams or event streams from a server. The problem there is if you have a lot of clients doing that, they all get individual subscriptions. So that's fine for most of the applications that are like dynamically changing what they are interested in, like in HMIs or configuration applications. You need this level of dynamic adaptation to what the client is interested in. But for large scale, that's a problem. And so the concept for the PubSub extension, publish subscribe extension, is that the information that is collected and then sent out as messages through a middleware is configured independent of the receivers. So somebody decides this information needs to be sent out, and then the middleware takes care about the distribution. And it's not the task of the device, especially the little ones that want to serve like 1 million subscribers. There is no way to do that today. And with this model, it's just up to the middleware to deal with this 1 million subscribers. And it's not longer a problem of the little OPC UA device. There are different steps what we are working on, and on the left side you see more or less the general mapping of OPC UA information to what we call data set. So you can select either a list of variables that go into such a data set, or you can subscribe for events or select events. So every event would then create a data set. And so this is all OPC UA specific, so it defines how existing OPC UA constructs like variables and events are mapped to a message creation. And then on the right side, depends on the communication protocols and the encoding. So we are working on a OPC UA binary encoding, so for optimized transport and also like for end-to-end security. But we also have a JSON encoding, so that is mainly used like with message brokers or cloud environments. And then there are different communication protocols that can be used, like we have a UDP-based protocol for peer-to-peer communication, and AMQP for cloud connectivity for talking to a message broker. And the two main models is either peer-to-peer with UDP, and there the messages are sent by the publisher to a multicast group. So the UDP multicast is doing the distribution of the messages. So there's not really a middleware in between. The second model is a broker model where a standard communication protocol or broker protocol like AMQP is used to connect the OPC UA application to the broker. And then what happens on inside the broker and on the other side is not always OPC UA. So if you combine that with JSON messages, even on the subscriber side, you can have applications that know nothing about OPC UA. So one of the biggest tasks that we worked on was security for PubSub. And it's if you go back, if you use just security to talk to the broker, then you just use whatever the protocol suggests, like TLS for transport encryption. My head is too big. Too much OPC UA in it. What we had to solve is like the end-to-end security. So either if you don't trust the broker, so you want to make sure that nobody that can access the broker can read the messages, only the sender and receiver can read it, or you have like a multicast UDP environment, then there is no middleware, so we have to come up with our own security. And in the client-server security model, we use just certificates like web browsers do, like regular IT technology. And they are used to then create session keys, and we use session keys for more optimized per message encoding and encryption and creating signatures. And these session keys are frequently rotated, so the standard setting is 1 hour. So every hour you get new session keys. For PubSub Security, the problem is these session keys must be shared between all publishers and subscribers that want to talk to each other. So it's not a point-to-point, it's a one-to-many or many-to-many. So it's a completely different problem to solve. And so we came up with the concept of a security group. So everybody that has access to a security group can read and write messages to that logical group. And the keys are managed for that security group. And all the messages that are sent then in with the keys for that security group. And the advantage we had was like we had already a working security concept, a proven security concept, and we just said, okay, let's reuse that for the key distribution. So either the publisher can provide the keys, and the subscribers can get the keys directly from the publisher, or there is a key server that all publisher subscribers can talk to get the keys. And the authentication authorization is done like based on that group and can be configured also. So we're also working on a standardized authorization framework for OPC UA. And like one example for what is one of our most important use cases, the controller-controller communication. The idea is that we have a standard configuration model, so you can go in from just any standard configuration client. You can go into one device, set up a data set you want to publish, set up the publisher settings like cycle time and frequency and address, or like of the multicast address. And you can go into the subscribers and you can do the same thing. So you can, for example, configure a Beckhoff PLC to talk to a Siemens PLC just with a standard configuration model from a standard OPC UA client. So there's, like for the controller-controller communication case, we have the requirement for real-time communication. And the problem there is you have to solve first, like make your system itself real-time capable. And so that means the OPC UA part of the communication needs to be real-time capable, and needs to be efficient. So what we already achieve with UDP Multicast and the PubSub model is that we have capability to send cyclically data in the same amount, configured amount of information, and it's designed to be very efficient, and so there's not a lot of compute power you need to create these messages and send them out. So we fulfill already like the requirements like inside the application and for sending the messages. The problem today is like standard Ethernet is not real-time capable, and so we don't want to come up with another incompatible extension to Ethernet. And so the reason why we think we can now solve that problem is a working group inside IEEE called like Time-Sensitive Network Task Force, and they are working on extensions for standard Ethernet that make standard Ethernet real-time capable. And we are more or less layering on top of these extensions with OPC UA, and there's a lot of interest in that topic at the moment. So other features we're working on is what I initially said, like in the use cases, is that relay functionality, so that you can talk from a client to a server through a relay. And the transport protocol we are using to that relay is AMQP. And there we can benefit from our message-based security. So even you can use a relay you don't trust, because you can encrypt the messages from server to client end to end. So there is no way to look into the messages even if you have control over the broker. We are working on new user token types based on OAuth2. That's a standard that is commonly used like in modern web applications. And we also work on an authorization framework for OPC UA, so you can configure down to a node and attribute level. You can configure the access for different roles and users. And we need that, for example, for the security group configuration for the key exchange for PubSub. Yeah, and there are some other things like extension to file transfer functionality, and there's also extensions to alarms conditions model, because there's a new IEC alarm specification, and we got a request from that group to add all the features they have in their specification to OPC UA alarm model. So that's also things that go on at the moment. So there are a few subgroups inside the OPC UA working group. One is the security working group, and they are mainly working on feedback that comes from the industry and from research projects, and discuss enhancements to the security options of OPC UA. There's a PubSub prototyping working group that has over 70 members. And the first thing this group produced that was publicly visible was at the Hanover Fair this year. So you can see already a few devices that use OPC UA PubSub to talk to a subscriber that is running on that screen. And we will update that demo for the SBS IBC drives in November. And so this is an important part of finishing the OPC UA PubSub extension, OPC UA. And then we have this TSN Evaluation working group. It has also over, I think the number is now over 70 members. I think 81? Yeah, it's growing every day. Last time I looked, I think it was around 75. And the main task of this working group is to, at the moment, to make sure that what we define in OPC UA Pub-Sub is not a problem when TSN is finished, and to come up with necessary definitions to lay out OPC UA on top of TSN. And the reason why it's not already part of the first release of the OPC UA Pub-Sub is that TSN itself is still work in progress. So important parts are already finished, but especially like the centralized configuration concept is still in the working groups. So the roadmap we have for the next specification release is that we do a lot of prototyping at the moment, and we want to have a release candidate in December this year. And then we want to finish prototyping, complete the PubSub implementation. So we have already a lot of stuff running, but there's probably a little bit more prototyping to do, especially with the final release candidate. And then the plan is to have like second quarter of 2017 to have the first release of PubSub. And the time frame between the release candidate and the release mainly depends on the progress of the prototyping working group. So that part will be more important then. And then after that, we will continue the work on the TSN mapping, which is hopefully not really adding a lot. So at the moment, it's just a few additional configuration parameters, it looks like. But we are still working on that part. Okay, so just to summarize everything up, OPC UA defines how information is exchanged, and domain experts define what is exchanged. And the PubSub extension is just the extension to the communication capabilities of OPC UA. It does not change anything for information models that are defined. So information model working groups are completely independent of PubSub extension. They just maybe want to know there are a few more capabilities for communication later on. And the idea is also for the application layer, you more or less update to the latest stacks and SDKs, and you have the PubSub functionality available for your applications that already support OPC UA today. And the only place where you need to change or add a little bit more is if you later on want to use also the TSN capabilities, because most of the OPC UA applications run not in the real-time kernel of a device normally. So there need to be some more extensions on this side. But for the non-real-time parts, the idea is that you just update existing software with additional modules and you have everything running. Okay, so that was my update and overview. Any questions?